Hello everyone and welcome back to our special DBMS Revision Series Explainer. A very special welcome to all the SPPU MCA students following the 2025 pattern. आज हम एक बहुत ही important topic समझेंगे जो आपके theory exams और practicals दोनों के लिए literally crucial है. We are going to completely master Unit 3 Functional Dependencies. So, get comfortable, grab your notebooks and let's decode this whole thing together.
So before jumping into any heavy technical jargon, let's ask a really basic question. What exactly is functional dependency, and why do we need it anyway? Well, imagine you have this massive, completely chaotic database. Lots of records, duplicate entries, data scattered everywhere. It's a total mess, right? How do you organize all that chaos into neat, logical tables? To do that properly, database designers need strict rules. They have to know exactly how different pieces of data are connected. Functional dependency is basically just that set of rules. It's the absolute foundation of database normalization.
Here's a quick look at our blueprint for today. We'll cover the basics of functional dependency, understand what a determinant is, tackle full and partial dependencies, break down transitive dependencies, and finally, look at all of this purely from an exam point of view. Let's get started.
Starting right off with Section 1, the basics of functional dependency. If you follow the logic here, it's actually super simple to score marks on.
Okay, so what is it? It's a relationship where knowing one specific piece of data, let's just call it X, helps you perfectly determine another piece of data, which we'll call Y. Simple language में सोचें. If I know X, can I accurately find Y? The answer yes है, तो इसका मतलब Y depends functionally on X. X is deciding Y.
Let's ground this with something familiar. Imagine your own college database with roll number, student name and marks. अगर आप अपना रिजल्ट चेक कर रहे हैं कॉलेज पोर्टल पे और मैं आपसे कहूं, hey, roll number 102 का नाम और मार्क्स बताओ. You can look it up and confidently say, name is Priya, marks are 92. You are absolutely certain there's zero confusion. Why? Because that roll number is totally unique. We write this mathematically with a really simple notation. Roll underscore no, then an arrow pointing to the right, followed by student underscore name, comma, marks. ये arrow बहुत important है. It literally means determines. Roll number determines student name and marks. A single roll number perfectly points to exactly one name and one marks value. And honestly, that's the whole core concept.
Moving right along to Section 2, Understanding the Determinant. Examiners love asking for this definition in short answer questions.
So, what is a determinant? The textbook definition says it's the attribute on the left side of the arrow that uniquely identifies the attribute on the right side. But if I explain this in simple English, the determinant is basically the boss attribute of your table. ये वो powerful column है जो बाकी columns की identity decide करता है. It holds all the power. Without the boss, the rest of the data is just lost.
Let's bring that back to our student marks example. In the relationship, roll underscore no determines student underscore name, look at the arrow. Left side में क्या है? Roll underscore no. So, roll underscore no is our determinant. और right side वाला, student underscore name, is called the dependent. Left वाला boss है, right वाला employee है, जो boss पे depend करता है. Make sense, right? Great. Let's level up a bit.
Section 3, Full and Partial Dependencies. Don't worry, a simple shopping app example will make this incredibly easy to visualize.
Let's say आपने Amazon या Flipkart से कुछ ऑर्डर किया. एक ही ऑर्डर आईडी के अंदर let's say O-01 आपने एक लैपटॉप भी मंगवाया है और एक माउस भी. यहाँ पर सिर्फ ऑर्डर आईडी से कोई यूनिक रो नहीं मिल सकती क्योंकि O-01 दो बार रिपीट हो रहा है. And simply using the product ID won't work either. हम एक यूनिक रिकॉर्ड आइडेंटिफाई करने के लिए ऑर्डर आईडी और प्रोडक्ट आईडी दोनों को मिलाकर एक कंपोजिट की बनाते हैं. They have to work together as a team.
Now, what exactly is full functional dependency? The rule is an attribute must depend on the entire composite key, not just a small piece of it. Take quantity for example. अगर आपको जानना है कि exactly कितनी quantity order हुई, आपको order ID और product ID दोनों पता होने चाहिए. सिर्फ ऑर्डर आईडी से क्वांटिटी नहीं मिलेगी और सिर्फ प्रोडक्ट आईडी से भी एग्जैक्ट स्पेसिफिक क्वांटिटी नहीं निकल पाएगी. यू एब्सोल्युटली मस्ट नो बोथ टुगेदर. ये है फुल डिपेंडेंसी. प्योर की पर फुली डिपेंड करना.
Contrast that with partial dependency. This is when an attribute depends on only a part of the composite key. Think about the product name. प्रोडक्ट का नाम, चाहे वो लैपटॉप हो या माउस, सिर्फ और सिर्फ प्रोडक्ट आईडी पर डिपेंड करता है। उसे ऑर्डर आईडी से कोई मतलब ही नहीं है। P10 is always going to be a laptop. So the product name is relying on just one half of our composite key. It breaks the rule of needing the whole key. और इसे ही हम partial dependency कहते हैं।
Just to lock this in, full dependency requires absolutely all parts of the key to determine a value. Partial dependency relies on just a single piece of a composite key. By the way, comparing these two side by side is a classic university exam question, so make sure you've got this distinction down perfectly. Moving to Section 4, Transitive Dependency Concepts. Stay with me here. This is the last major theoretical rule of normalization. Take a look at this employee database scenario. हमारे पास employee ID, department ID, और department name है. The primary key here is employee ID, but notice कीजिए कि यहाँ एक indirect relationship चल रही है. E001 belongs to department D5, and D5's name is IT support.
This is where transitive dependency comes in. Technically, it happens when a non-key attribute depends on another non-key attribute instead of linking straight to the primary key. But let's ditch the heavy jargon. ये basically एक friend of a friend वाली relationship है. A relies on B and B relies on C.
Let's walk right through this logical leap. Step 1. Employee ID determines department ID. The boss attribute tells you your department code. Step 2. Department ID determines department name. The code tells you the actual name of the department. So, step 3. Therefore, employee ID determines department name, but indirectly. ये जो indirect chain link बनती है, this non-key attribute depending on another non-key attribute, is कोही transitive dependency बोलते हैं. During database normalization, we actually have to remove these indirect links to keep the database running smoothly.
Finally, Section 5, Exam Point of View. Let's talk strategy and how you can actually score maximum marks on your paper.
What exactly are the SPPU checkers looking for? Here is your secret formula. Number 1, always write out the mathematical definition first. X determines Y. Number 2, draw a clean, small table for your example, just like we did with the student marks or the sales data. Number 3, explicitly write out the A determines B logic right below your table. And number 4, clearly highlight and label the determinant on the left side of your arrow. अगर आपने पेपर में ये 4 steps follow किए, there's absolutely no way you're losing marks.
Okay, let's do a rapid-fire revision summary to totally cement this right before you finish studying. Functional dependency perfectly relates data using the X determines Y rule. The determinant is your left side boss attribute. Full dependency uses the whole composite key. Partial dependency uses only a part of the key. And transitive dependency? That's just your indirect friend of a friend link. And that completely wraps up our Unit 3 explainer on functional dependencies. But before you go, think about this. If these simple rules are what organize our college results and online shopping carts, how crazy does it get when big tech companies are managing billions of rows of data every single second? Just imagine handling transitive dependencies at that enormous scale. Anyway, practice making these tables on your own. Agar video helpful lagi ho, to like, share, and subscribe zarur karna. Best of luck with your exams, keep studying hard, and we'll catch you in the next one.